Hey, Physics 30s, how's it going? We're going to be talking about de Broglie today. So it is pronounced de Broglie, not de Broglie or de Broglie. I think a lot of people make fun of his name, de Broglie. You might see that in a couple of videos there that I show you. But de Broglie is it's a pretty simple topic. All he did is just say if light, or say if things with wave properties like light can behave as a particle, why can't a particle behave as something that has wave properties? Just the symmetry of nature. If waves can behave as particles, particles can behave as waves. And it's true. It works. Electron scanning microscopes use this technology all the time. That's how an electron scanning microscope actually sees smaller objects than visible light or EMR, dangerous gamma radiation and stuff like that. So rather than using gamma radiation to picture something that's really, really small, we can use hyper fast or super fast electrons that have wave properties. And if they have wave properties, they'll reflect, they'll refract, they'll produce images. So we can produce images down to the molecular level this way, if we can get those electrons to have a wavelength of around the wavelengths that were of the distances that we have where we want to look at. So like in the femtometers and stuff, really, really small stuff. So that's all de Broglie said. And it was really, really easy. He just actually went along and just said, everything is just a wave, right? Anything with momentum, it has a wavelength, right? Everything that has a wavelength has momentum. That's pretty much all he said. Everything is then a wave, no matter what. So we are just waves of probabilities to him. You look at us, and the thing is, if we look at you, then all of a sudden that wave function collapses, and there you are, right? You've been measured or observed. And it gets a little bit trickier than that, but that's essentially his thesis, his process, and how it actually works. Then is that you just use the exact same formula from the previous video, where if I have a wavelength, I have momentum. So therefore, I have a wavelength. If I have wavelength, I have momentum. If I have momentum, I have a wavelength. That's all he said. I really just erase this, make this arrow look really nice. So many things I can do in life. Okay, so that's all I said. You argue that everything just acts as a wave, anything with momentum. And if you have momentum, so you can just calculate these momentums if you have mass by mass times velocity. So I could just do that calculation and just go h divided by mv. Pretty easy, not too bad. So this brings up this important topic of wave-particle duality. Everything that is a wave can act as a particle. Everything that's a particle can act as a wave, and back and forth, back and forth. And how an electron acts is just depends on how we interact with it, what's it doing at that time. So there's a lot of good videos here. This Dr. Quantum one is a really cool one. It's this double slit experiment using electrons. It's quite an interesting experiment. How it just blows your mind. So you should definitely watch this Dr. Quantum one. There's some other ones in here about the wave particle, how that could change the wave model of the atom, how the atom actually works. We're going to bring those ones back up. De Broglie pops up later on in the year as well when we talk about the new models of the atom. And yeah, so these are all really good videos. And I'm probably going to link a few other ones in there. One with Nick Lucid talking about the dual slit experiment, the double slit experiment involving electrons as well, and how things have changed quite a bit. How it's just kind of crazy. But let's do some examples here. You can watch those videos at any point. Just one second. Before I forget, I'm going to link one of those videos. Okay, so I'm back. I just added a few more videos to my lessons there. Forgot about a few. What is the momentum of a 500 nanometer photon of green light? Okay, so this is a pretty easy one. So we can calculate momentum of things with wavelengths by using, I keep on saying momentum with a line on top, but in this case, we're just worried about the magnitude of momentum. Okay. So momentum is equal to h over lambda. Remember, you're going to use for finding momentum, you're going to use the 6.3 6.63 numbers, sorry, to do this one, times 10 to the negative 34. And you just have to make sure that these are in meters. Okay, pull out your calculator. H divided by 500 to the power of negative 8. Negative 9, sorry. So we get 1.33 times 10 to the negative 27 kilograms meters per second. Sweet. Now, what is the wavelength of an electron moving at 10,000 meters per second? So I'm going to rearrange that same formula that's up there. Go H divided by P. Now to do this, I'm going to go M times V to find my momentum because it has mass. So not traveling at the speed of light here. And let me just put those numbers in there. 31 kilograms. So about 10,000 meters per second here. I'm going to punch this in my calculator. Also, I would have been smart to put electrons mass in my calculator as well. That's okay. So H divided by 9.11 to negative 31. Oops, I should probably put that on the bottom there, 10,000 as well. Cool. So I have a wavelength of 7.28 times 10 to the negative 8 meters. I want to change that into nanometers because that's a nice way to communicate some of these. So this is 72.8 nanometers. It's actually quite small. You know what I think about that. Okay, so that's pretty much it. We're not going to talk about like super fast electrons because as soon as they go faster and faster, they start gaining energy, they start gaining mass. It's called relativistic momentum as well, so they start gaining the momentum. That kind of throws things off. So usually we forget about special relativity and general relativity at the same time. So we just keep our speeds relatively low. It's like here's 10,000 is a pretty small number here. Okay, so that's it. So that ends off this chapter. There's a couple of fun little videos here. You don't have to know too much about Heisenberg's uncertainty principles. It's just fun things to know about physics. And I will see you in the next chapter or any other of the videos that I do. I'll see you then. Bye.